Hello, my name is Mark Shipman, and today I'm going to be talking about how recent advancements in reliability theory and data science can help build more reliable supply chain networks. I have 25 years of modeling experience, and I specialize in scalable solutions for reliability problems that include renewal and risk management. Today, I will present a solution that demonstrates that GS1 enables real-time, resilient, optimal, risk-aware analytics. So to begin, let's imagine a supply chain. It begins at a source. There's transportation to some warehouses or intermediate points, and there can be multiple, and then it ends at some sort of consumption. This is a simplification. There can be many different configurations, but just for the purposes of this discussion, I'm going to simplify it into beginning, middle, and end. GS1 enables tracking of products through this entire supply chain. The data that we're interested in for this solution is flow data. How much of a particular product is going in and out of a given node. From that data, we can reconstruct a virtual supply chain without having to know the exact path of a specific product. We just know the flow, what's going into a node and what's coming out of a node, and then we can reconstruct the supply chain virtually. With a virtual supply chain network, we can estimate flow at the intermediate nodes, at the source, and at the endpoints. We can measure risk, and from that we can estimate the impact of a disruption. You can attribute risk to each node, each component of the supply chain, and then you can also optimize parameters for a given risk tolerance, such as inventory target levels and supply chain routes. Using grocery store sales data that I downloaded from a Kaggle competition, I was able to build a prediction model for the demand of the grocery store sales. The model had an R-squared of 90%. Part of the reason that the model performed so well was because I was able to cluster stores together that were similar. GS1 data would allow stores to be clustered based upon similarity, which would improve accuracy of demand forecasts. Once we have the flow estimates for each node of the supply chain network, it is possible to simulate the supply chain cycle from demand to orders to production, transportation, and sales, and then back to demand. This cycle can be simulated. We can use those flow estimates and the flow data to estimate the dynamics of this cycle. In this example, we can see that a very low inventory target results in significant understock, and a very high inventory target is unnecessary. We can also see that the optimal profit point requires some possibility of understock. Trying to avoid being understocked increases inventory costs to the point where it's counterproductive to profit. Because the system is based upon real-time data, it will automatically be updated whenever there is a change or a configuration to the supply chain. Making supply chain decisions that are based upon real-time data and that are optimized to be risk-aware will help shorter supply chains to be more versatile and resilient. This concludes my presentation for the 2022 GS1 US Hackathon. Thank you for watching.